Good morning, ladies and gentlemen. Do this now. I want you to go to page 123 in the e-text, and it looks like this. And I want you to literally transfer this information from the book onto here.
Types of force,
Weight, tension.
symbol, definition, direction.
What do we have over here? Force, types of force, symbol, direction, definition.
Why would we be asking him to do something like that?
You know, just to get familiar with the terms, you know. Let's talk about weight. And I've been kind of alluding to weight. Here is our formal definition. Weight is the force of gravity pulling down.
And how do you find weight?
The same way we find the force of gravity. Mass times the acceleration due to gravity.
That's it.
Times g. So if you want to know what the force of gravity is pulling down, it's the same thing as your weight on the earth. Okay. Find this in your notes, ladies and gentlemen. We did this yesterday.
We did this yesterday. Can you find it?
Can you find it? What is your mass in kilograms? What is your weight in newtons? Okay. Oh. Also review.
Let's just skip
Keep
this.
on going?
Yeah, we did this yesterday.
If you can find the previous one, you can find this one. Okay.
Yeah.
Okay, so back to we just said that weight is the force of gravity pulling down, and now we have this thing called the normal force, F, and then that's an N, F sub N.
And you should have done this, got this out of the book.
Oh yes, you should be familiar with this.
And put it onto the worksheet.
So the normal force is the force exerted by a surface perpendicular to the surface at a point. This is the force up.
Yep.
This is the FUP.
We've been calling it FUP.
Yeah, and we're giving it a new and improved name. And what's really important is that if this is your surface right here, it is perpendicular to the surface. Surface, perpendicular.
That's right.
I was going to use the knife, but I thought maybe...
No, not a good idea.
Okay, a bathroom scale measures the normal force, the FUP,
Yep.
right? Let's go ahead and play this for them.
I love this video.
And as you're watching, you know, the goal is to pay attention to the scale. What is going on with the scale? And you guys have all been in an elevator before.
Have you? There are not many here in Merced.
Shoot, maybe you haven't. Well, if you have, then you're familiar with that feeling you get when you move on the elevator. Makes your stomach kind of lurch.
Here's a kid in an elevator. Ground floor. How much does he weigh?
Looks like
24.
124.
All right.
Okay, so right now it's at 124. And what do you think is going to happen to the number on the scale when the elevator goes up?
It's not going to go up forever. It'll have to go up and stop. But what's the scale going to do? Here we go. Whoa! 130. Oh, and now 124.
So it went up to 130, then back to 124.
He's going to come to a stop here in a minute. What'll happen? What'll happen?
Whoa!
Oh! 118.
Fourth floor.
And back to 124. Those are some funky shoes you're wearing, child.
Okay, so now
He's going to go.
he's going to go back down. And what is going to happen to the number on the scale when the elevator goes down, and then when it comes and then when it comes to a stop?
Right. So what's going to happen? What's going to happen to the numbers? 124 going down. Oh! 118.
It's like you lost
Oh,
weight.
back to 124.
What's going to happen when it stops?
130. Dude, how'd you do? Back on the ground floor again. What does this makes you wonder? That's a college student.
Yeah, this is college student, you guys.
Yeah, well,
Okay.
it's probably not a native English speaker, so.
Should we talk about this?
Yeah, the bathroom scale is measuring the force up, the normal force.
Yeah, so you step on the scale and the force of gravity is pulling you down, but what it's really measuring is the FUP, the normal force.
Yeah.
And what we saw was guy was on the elevator with his super cute shoes, and he had a mass of 124 pounds,
Yeah.
right?
Well, that was his weight.
Sorry, excuse me.
And
It was
did
his
his weight change?
His weight did change. Well,
No.
his real weight didn't change, but the number on the scale changed, which means that the normal force changed.
So it's not measuring the weight, it's measuring how hard it has to push up to keep him from falling.
So his weight didn't actually change, but the
No.
normal force changed.
That's right.
Let's talk about this real quick. So 124, and then as he went up, it got heavier, right? Went to like 130,
Yeah, and you ever been in an elevator and had that funny feeling in your stomach when you go up?
right? And that's because of inertia, and when you move up, your skeleton, your body moves up, but your organs, your intestines, they want to stay where they're at, right?
Yep.
So there's this feeling you've got in your stomach. So he goes to 130, and then once he gets going at speed, it went back to normal, right?
Right, it was just fine.
Yeah, and then when he came to a stop at the top, what happened there?
You got light.
He got lighter. Okay, so we see this change, but basically what's going on here is that it's measuring the normal force, the force up.
Yep.
Okay. If acceleration occurs, there is a net force.
Oh yeah.
Yeah. And so we can look at this at the net force like this. We can add up what's going down plus what's going up.
Yeah.
And we can break this down even further. The net force is mass times the acceleration.
Yep.
The weight is the mass times gravity.
Yep.
Gravity because we're being pulled down. And then we've got the normal force.
That's what the scale is showing.
Mm-hmm. Where's my mouse? There's. Okay. Oh, let's do a practice problem. It says 70 kilogram Miss Moore pushes the down elevator button and accelerates at 1.5 meters per second.
What's the scale going to do? Stay the same, go up, or go down? She's going down. What's the scale going to do?
What's going to happen? Well, as I go down, as the scale goes down,
The floor drops out from under you.
the floor drops out from under me. I'm going to be a little bit lighter.
That's right.
Lose weight instantly, okay? My first question, well, what direction is the acceleration?
Oh, well, going down.
I'm going down, so my acceleration is 1.5 meters per second squared down.
In the negative
or
direction.
negative, right? Okay, let me go ahead and start drawing this. Whoa. So here's me. Oh, I've been reduced to a dot. And let's start with 70 kilograms. I know that the force of gravity, which is the same thing as my weight, is mass times gravity, which is my mass, which is 70 kilograms,
I wonder if that's still on the calculator.
times negative 9.8.
686.
Thank you, sir. Negative, right?
Yep.
Okay, so we used to be able to just make the force up the same, but we
Well,
can't. Why?
Let's find out the net force first.
Yeah. So, well, first of all, what direction is the acceleration?
Sorry, my bad.
It's what direction is the acceleration?
Down.
Well, down. Okay, down. I'm gonna say negative 1.5. We already said this, but I just didn't write it yet.
Yeah.
Okay, and then what's the net force?
Well, that's mass times acceleration.
Always. Now, my mass is
70.
70 kilograms, and the acceleration is
1.5. Negative 1.5, my bad.
meters per second squared. So my force net equals 70 times a negative 1.5.
105, I'll bet.
70. Oh wait, yeah. Negative 1.5, and we get negative 105. Negative 105.
I notice it's negative, so's the acceleration. That's because
The net force and the acceleration are in the same direction.
always, never an exception.
So because our acceleration is negative 1.5, we know that this one has to be negative something.
All right, what do we do next?
Okay, so what was the question? What is the net force?
We
Draw
got
a
that.
complete body diagram.
What have we left out?
Okay, well, now I'm not going to draw these the same length because they're not the same. This is the normal force, the force
Because the
up.
scale's going to show a smaller number as the floor drops out from under you on the way down.
Exactly, so I drew it a little bit smaller. Maybe you can't really tell there, but it's smaller, okay?
So net force means two things. We've already got the mass times acceleration. What's the other thing the net force means?
The net force can mean that, or the net force can be the forces added up together. So in this case, my force of gravity, which is going to be a negative number, and my normal force, which is going to be a positive number. Okay.
All right, so we
So
know
this
the
plus this.
net force. We know the force of gravity. How can we solve for the normal force?
If we're trying to figure this out, I guess we could just subtract this and put it over here,
I
right?
think so. That's subtracting and, wait a minute, subtracting a negative? Yeah, it is subtracting a negative.
Okay, so I'm gonna go ahead and I'm gonna carry through the negatives the whole way. So this is gonna be minus the force of gravity, but keep in mind this is a negative number, so we will be subtracting a negative number later.
Of course, the net force is also negative, but
Oh yeah, oh, actually it is. Let me make a little note of that, right? So this number should also be negative, and this number right here negative.
yeah,
Okay. So I just like to carry them through like this.
that's always a good idea.
Yep.
And that'll give us the normal force.
It's
Force
gonna be a positive.
normal.
Okay, now again, let's break these down into our components. Now look at the previous slide, look at your notes, what you wrote down. Okay, we've already done this. So our net force is gonna be this, and our force of gravity is gonna be, or weight is gonna be that.
Yep.
Okay, so our net force we said was mass times acceleration. Again, this is gonna be a negative number.
Oh, we've already got it.
Yeah. Oh, we do.
Yeah, we've already
Let's
got
put
all
it
of
in
them.
there. Oh, you're right. What am I doing here?
Just put them numbers over there.
I'm so used to writing it all out that I forgot. Okay. Okay, so what was my net force?
Negative
105. And that's, now, it's important because it's a negative number. We see that. It all checks out. Minus, now what was my force of gravity?
Negative 686.
Negative 686. Now, this is just like a little cheat sheet, you guys. This tells you what it should be. And when we add these together, we're going to get our normal force. Thank you, sir. So negative 105 minus a negative 686. And I get 581.
581. Positive.
Positive number. Looks good. So this is no longer a question mark. It's now 581.
And that's what we saw in the video. When the push the down elevator and at the start, there was less weight that showed a smaller force than the force of gravity.
Yeah, in the video, the dude started off at, what was it? He's kind of 124. This guy's a scrawny dude.
Pencil neck.
Yeah, I started off at 124, and then it went to as soon as it went down, he went to
118.
118, right?
Yep.
So 124 to 118 when we down. Same thing here. We started off at 686 newtons, and when it goes down, all of a sudden the scale would read 581, which is less. We see the same thing here. It's
So,
less.
mathematics are wonderful things they can use to predict and justify. They reflect what we saw in nature.
We're done. Okay, read page 126 to 129.
Okay, the challenge here is don't fall asleep while you're reading. Do not fall asleep.
Don't do it. And that looks like this, 6.2, chapter 6.2,
Yeah.
126. And then on
This
page... Exciting stuff. Oh. And then when you get to 129, you're going to do number 13.
You can do this.
You can do it. Okay, that's it.